Now, because groundwater pumpage for the pipeline does not involve increased recharge, you needed either increased recharge to balance pumpage or reduce discharge. With a pipeline and a pumpage for that pipeline, pumpage does not involve increased recharge. You're just taking it out of the ground and moving it into the Prescott active management area. And since discharge to the Verde River is, Big Chino is to the Verde River, that's what gets hit. The Verde River, discharge into the Verde River will be reduced because of that pumpage. Okay. This conclusion is supported by the 1994 U.S. Bureau of Reclamation report that stated that results of this investigation suggest that groundwater pumping in the upper Big Chino Valley would have an adverse impact on the flow and perhaps the biota of the Verde River. The decrease in discharge to the Verde River will occur regardless of where you put the wells. If you put the wells close to the river, the decrease in discharge happens faster, that's all. By moving the wells further away, you delay the time that the impact occurs. Because there are some trees around the Verde River that put the roots into the water table, the groundwater system, you may lower the groundwater table enough that those trees stop taking water out. And there'd be some loss there, but it's very small compared to how much water goes into the river and how much would be lost by the river. Next. This is a thing to show you that if you start pumping and time is going along this way, the impact on the river, for a while there's no impact. The reason for that is when you pump, the water levels decline away from the well, and they have to spread further and further away from the well until they ultimately reach the river. Once the water levels decline from pumping and reach the river, then the river begins to lose water, and it loses water in this fashion. This time can be measured, the time that no effect occurs can be in years, days, decades, decades perhaps. This time can be in days, years, decades, and perhaps even hundreds of years before it gets down to here. But the impact is occurring after a decade or so in the Verde River. Next. Okay, now here's an example of what actually happened next door to the Big Chino. We'll go to the Little Chino Valley. Now, groundwater in Little Chino Valley is known to move towards Del Rio Springs and towards Big Chino Valley, which is up in here. A major discharge point for the groundwater system is Del Rio Springs. Groundwater pumpage in Little Chino Valley started about 1939, and it's this is groundwater pumpage, this is time in years. Groundwater pumpage started about 1939, and it's generally ramped up, although it's come down, but there's been a general pattern of increased pumpage since that time. This is what's happened at Del Rio Springs. The discharge was just in the neighborhood of 4,000 acre-feet a year from the springs back in 1939. And since pumpage has started, it's gone down. The values here, the triangles, are model predicted. Arizona Department of Water Supply, of Water Resources, created a model of the Little Chino. They used that model to put the pumpage on it. The model predicted this decrease in Del Rio Springs, with the Del Rio Springs going dry in 2025 for existing pumpage at Little Chino Valley and Prescott AMA. The observed is the purple. You can see they're very close, and the observed is going down. So in the Little Chino Valley, pumpage has, we can demonstrate its impacted discharge for the groundwater system for the reasons I've stated. When people say it won't happen in the Big Chino, they are ignoring the most basic concept of groundwater hydrology, that all pumpage is balanced by a loss of somewhere, by a loss somewhere of water. Now, that's the end of my talk. I think I made it 10 minutes.
You did great.
Then Wolf will take over for the second part of this.